All right, this next lesson for chapter 2 is all about chemical bonding. And this is actually one of my favorite topics because I love how things can change their properties purely by how they're bonded together. So for example, if you take pure sodium that hasn't been changed at all, it's not an ion, it's just plain old Na. It's a soft metal and it's extremely explosive when you put it into water. And we used to be able to do that demonstration for students. Now it's banned in Wake County because of it's so dangerous. But and then if you our next topic for this chapter is about chemical bonding, which is one of my favorite topics because it's really interesting to me how things can change their properties completely purely by bonding together, which by changing their bonds. So for example, if you take pure sodium, just plain old Na, and you drop it into water, it's extremely explosive. So pure sodium is really reactive and really dangerous. And then if you take pure chlorine, it's actually a gas and it's extremely toxic to breathe in. But if you bond them together, so if sodium loses its electron and chlorine gains an electron, they become charged particles and they will stick together, you get table salt. From an explosive metal and a toxic gas, you can make table salt. So to me, I think that's so cool how just purely rearranging the electrons will change all of the properties of the atoms and compounds. So let's just go over a few of these. I know we did some in the review. Ionic bonding is exactly what it sounds like. It involves ions, which are charged particles, and opposites are attracted. It's usually a metal and a nonmetal, so metals usually lose their electrons, nonmetals gain them, and so it's a perfect marriage where you get a positive and a negative. However, you have to be careful because you could have two polyatomic ions together. So for example, ammonium is NH4 positive, and then like nitrate is NO3 negative. So even though it's a covalent bond that holds the polyatomic ions together, because each group of atoms has a charge, it's an ionic bond that holds the charges together. The smallest unit for this is not actually a unit, it's actually a ratio. So when we write table salt, we always write it as NaCl. It does not mean that you have a little marriage of one sodium and one chlorine that are floating around together as a partnership. What it means is that you have a big crystal with lots of sodiums and lots of chlorines, but the ratio of ions is 1:1. So for every sodium, there's also a chlorine. So the formula unit is actually a ratio of ions within the crystal. And it's not an independent unit. Independent means it exists all by itself. So like I said, it's not like a little family of ions floating around together. It's a ratio. These are some vocab words. Cation means positive. Don't say it cation or cation. And anion means negative. And the way I remember that is just look for that lowercase t. It looks like a plus sign. When they attract, it's just an interaction between opposite charges. And the ionic compounds are often called salts. So be careful with that. A lot of people who are not familiar with chemistry think that when we say salt, it means table salt, which is NaCl. But in chemistry, the word salt just means any ionic compound. So any positive and negative ions together, you can call that a salt. And the ions could be just one type of element, or it could be, like I said, a polyatomic ion. Covalent bonding is, instead of transferring electrons, now they're going to share electrons to meet that octet rule. So they're still trying to become stable. This next unit is all about chemical bonding, and this is one of my favorites because it's really interesting to me how things can change their properties purely by how they're bonded together. For example, if you take pure sodium, it is extremely explosive when you drop it into water. If you take pure chlorine, it's a very toxic gas that you would not want to breathe in. But if you bond them together, so if sodium loses its electron and becomes positive, it transfers that electron to chlorine, which then becomes negative, and that positive and negative will stick together to form sodium chloride. You get table salt. So it's just crazy to me that you can take an explosive metal and a toxic gas and mix them together, and when they stick together, they form table salt. So first of all, just a general definition about bonding. The reason that things bond is to become stable. And actually, that's the answer to most of the questions for why does something happen in chemistry. It's almost always because something is trying to become stable at a lower energy. And the way that they form bonds is based on the octet rule, which says that most elements or most atoms are stable when they have a full 8 valence electrons in their outer shell. So ionic bonding is the attraction of oppositely charged ions. It's exactly what it sounds like. The electrons are transferred, and it's usually a metal and a nonmetal. So metals lose their electrons to become positive, nonmetals gain them to become negative. There is an exception though. If you have two polyatomic ions, then you would have a covalent bond that holds the polyatomic ions together, but ionic bond between the two ions. So for example, if you had NH4 plus and NO3 negative, the covalent bonds would be holding the NH4 together and the NO3 together, but then ionic bonds would hold the NH4 to the NO3. The smallest unit for this is called a formula unit, and it's not actually a unit at all. It's actually a ratio. So for example, when we do table salt, we write it as Na1Cl1, like there's just one of each one in the formula, but it doesn't mean that it's just a little partnership of one sodium and one chlorine. It means that in the big crystal that has lots of sodiums and lots of chlorines, the ratio of sodium to chlorine is just a 1-to-1 ratio. There's a few vocab words. Cation means it is positive, and remember, if you look for that lowercase t, it looks like a plus sign. Anion means it is negative. Try not to say them as cation, or anion, even though that's what they look like. And one more thing is that they could be called salts. So be careful with that word. In the real world, when we say salt, we usually mean table salt, which is NaCl. But in the world of chemistry, salt just means any ionic compound. So it could be any metal bonded to any nonmetal, or even polyatomic ions. Covalent bonds occur when you share electrons. So they're still trying to meet that octet rule, but instead of transferring the electron from one to another where you get opposite charges, this time they're going to share electrons. And it usually occurs between two nonmetals. Down here is an exception. So this, you can see, is two different polyatomic ions. So even though this whole compound is made up of nonmetals, it actually has an ionic bond right here between the two polyatomic ions. So covalent bond is holding the NH4 together, but ionic bond is holding the NH4 to the OH, because each one of those have charges. The smallest unit for this is a molecule, and this does actually exist independently. So for example, H2O is 2 hydrogens and 1 oxygen, and those 3 atoms are kind of stuck together and they float around as a little family of just those 3. When we represent molecules, a lot of times we just write the formula. So H2O, we just tell you how many of each one we have. So the 2 means that you have 2 hydrogens. Sometimes we'll draw the pictures. We'll do the Lewis dot diagrams to actually show the molecules. And remember, each line represents an electron pair being shared. All right, and then polarity and intermolecular forces are some big topics that we're going to continue to use throughout the whole year. Polarity is an uneven sharing of electrons, and the AP exam likes to hear you say things like it's an uneven distribution of the negative charge. So it basically means that one side of the molecule is more negative than another side. And I'm going to do another video in just a few minutes to go into a little bit more detail, and I'll show you some pictures that has some examples of polar and nonpolar. And then intermolecular forces, inter means between. So this is a force of attraction between the two molecules. Not within the molecule, that's a bond that holds it together. But if you put 2 molecules next to each other, it's the force of attraction that will hold them together. And again, I'm going to do another video in just a few minutes where I'll actually show you some examples of these. These are the different types. So if you want to go ahead and take notes on them, in the next video, I'm going to draw some pictures of each one of these and show you kind of what they look like and give you some examples of each one. So if you want to pause it and take any notes that you need to, you can, and then be sure to watch that second video where I show you some examples. And then the last thing for this lesson is the periodic table. There's a few areas that you need to be familiar with. There's a staircase located kind of to the right side of the periodic table. The metals are located on the left, and the nonmetals are on the right, and then metalloids are on the staircase. And there are a few exceptions to that rule. So, for example, aluminum looks like it's a metalloid. It's on the staircase, but it's considered to be a full metal. And then hydrogen you have to be really careful with. Hydrogen is way over on the left, so it looks like it's to the left of the staircase, which would make it a metal, but it's actually a nonmetal. So be careful with aluminum and hydrogen. And then these are some more terms. Periods go left and right. So just think of period goes at the end of a sentence, and sentences are horizontal. So these are things that are horizontal. And then family or group, think of family tree. Family trees grow up and down. So these are vertical columns. And then elements in the same column, the reason we care about this is because they're going to have similar properties. So that's why we say that they have, sometimes we call them a family, just like you probably have similar properties to people in your family. You might look like people in your family. You might have similar values or have similar interests. And it's the same thing with elements. So they tend to have similar properties, and that's because they all have the same number of valence electrons. And be careful with that. A lot of people confuse that with the atomic number. So just as a reminder, atomic number is the number of protons, and that purely just identifies which element it is. It's the valence electrons that determines the properties. And what I mean by that is, for example, when I told you that sodium is really reactive, that's because it only has one valence electron, and it's pretty easy to deal with just one. So it's going to do that really fast and violently because it can get rid of that one electron really easily. So the valence electrons determine the properties, and the atomic number determines the identity. These are some family names that you should probably be familiar with. Group 1 is all the way on the left. Those are called the alkaline metals, and like I said, they're extremely reactive because they just have that one valence electron to lose. The group right next to them are called the alkaline earth metals. It's confusing because they both kind of have alkali in them, so I just remember that alkaline earth is 2 words and it's in group 2. Also, alkaline is a bigger word than alkali, and group 2 is a bigger number than group 1. And then if you skip way over to the right, the second to last group is called the halogens. These are the most reactive of the nonmetals because they only need to gain 1 electron. And remember, losing or gaining 1 electron is pretty easy to do. And they're also known as the salt formers. Sometimes it's a random multiple choice question on an AP exam. And then the last group farthest on the right are the noble gases. And these already have everything they need. So most of them have 8 valence electrons, which meets the octet rule. The exception there is helium. If you did the electron configuration for helium, you would see that it's 1s2, and that's all it has is just an s. And so it's actually stable because it's completely full, even though it only has 2 valence electrons. So all the ones under it have 8, but helium only has 2, but they're all stable, and so they don't react. And sometimes you'll see the word inert for these. Inert means that it doesn't react with other things very easily. You can force them to react, but they don't do it on their own, usually. All right, that's it for this video, but like I said, I have another video to do some examples for you.